This is Vaibhav again from TechRail, and in this video I'm going to revisit the tasks that I had set, and I'm going to create issues in the code hosting solution that I'm using. Speaking of which, as you can see on screen, I am hosting it on forge.techrare.in. The reason it is called so is because this is where I'm gonna host it, and this is my timeline, okay. And if you try to open it from somewhere else, so you can go to File, New, Private Window. So that's incognito for Chrome users, and you put in Enter. You'll get this. This is powered by 4JO. I guess that's how it's pronounced. I'm not sure. And it is a code management system written in Go as well. And it looks like an older version of GitHub, more or less. But if you go to the server where I'm hosting it, you will not be able to register. There's no registration possible here. And this is by my decisions. I don't want to expose it now. And if you go back to the chamber project over here, if you try to open this in the incognito or the private window and you press enter here, you'll not be able to find it, okay. And once I make it public, and that is because this repository is not yet public, I guess you where did it go? Make this repository private, yeah. So if I remove this and save settings, that will basically make it accessible to everyone. Now, like I said, this looks like an older version of GitHub. For those people who are new to GitHub, this is how GitHub also looked, I guess 5 or 6 years back, before Microsoft acquired it. After they acquired it, they have done a lot of changes and a lot of features have come in, but this is how more or less GitHub looked like. Obviously, this is much smaller, and the features are pretty stripped down, but it has enough features for me to work comfortably. It has got issues, it has got pull requests, you can manage projects, releases, and more with this. And trust me, it takes very less amount of server resources to run. So that's what I use. And I am on version 11.0.1, as you can see here. So in the last video, I think I stopped somewhere here, and I wanted to organize the list of things that I want to do in chamber and create an issue for every single one of these entries, right? I mean, not the ones that are actually done, but for the ones which are not yet done, I want to add some details and create branches against those, because right now everything that I do is basically on the main branch, and that's not always great, right? So that's what I'm going to do in this video, and I'll probably start with reading pragma directives and writing those. I'm not sure whether I'll be doing this right away or a little bit later, maybe in a separate video, but let me first create the issues for these tasks, okay. So okay, I've already opened it. Let's go to issues, create a new issue. Let me copy it from here. So when I say make the encryption system, let me elaborate on that, and that is why it is one of the reasons why I want to create issues against those tasks, so that I could remember the details of what each item was about, and if I need to consolidate ideas or make notes or assemble bookmarks that are useful to those ideas or those problems, I could do that using issues here. So let me start with that. One more thing that I want to point out here is this is running inside Docker on my rented server, and the database that it is using is actually, if I go, okay, let's stay on page on this one. I can go to site administration here, and okay, update is available. But if I go configuration and summary, SQLite, I'm using SQLite. Yep. So the database that is backing this installation of 4JO is actually SQLite on my server. I mean, it is SQLite database that was created by this project, this installation of 4JO, and that is what it uses. I had previously created one using Postgres. I guess that at that time I was using Gitia, which is the parent project from which 4JO comes out. And it was a little bit messy for me to maintain, keep checking on that. And SQLite honestly is performant enough and has got enough features that I am not finding any problems in either performance uh, or feature. I don't think that features would be a problem since 4.0 takes care of which database it is using underneath. So, okay, let's proceed. So, making the encryption system, right? What is the current state and what do we want to achieve? So, let's start with that. So, right now, we are doing a very basic hashing of the password entered by the user on the CLI. Need to design the 8-step hashing plus encryption key derivation system and use it everywhere. We are trying to everywhere we open the chamber, either when we create it, use it. When I say it, I mean module, that would module or a function that will take care of this functionality. And we open the chamber when we create it, or feed it to decrypt any content inside, to encrypt or decrypt, content inside. I am so used to using the Vim or NeoVim key bindings, the J for up, down, and K for up, and H for left, and W for word jumps, and B for back, things like that. That I feel like those bindings should be present everywhere, and that's a bad addiction to have. Let's create the issue here. All right, one has been created. Let's create one for this. Let's go and create new issue. Let's see. Oh, okay, I can't use that. And once again, let me see if this works. Add code. Yeah, nice. This is code, and list of tasks and nest items at table. Wow, haven't really explored this. Any monospace? Nice. I like monospace. I work with monospace everywhere. This is to make sure that we use the same term everywhere. Both in code as well as in documentation. Okay. Create an issue. Let's go back. Read pragma directives. Okay. Let's create new issue. Ability to read and set pragma. See, this works. Pragma directives. Oops, sorry. When we start chamber, we would have to rely upon certain behavior that we would expect, certain behavior from SQLite. For example, we would need foreign keys. Foreign keys enabled. Journal system being set to wall, and this is for now at least. What else was there? Synchronous disk writes to avoid the data corruption. And so on, right? So we need to create a set of functions which we can use to check if those settings, pragmas, have been applied to the current connection or not. Okay, let's create an issue for that. Yeah, good enough. Also, I think there was one that I'm forgetting. Okay, whenever I remember that, I'll create an issue. I'm not able to recall it now. Make CP work with directories. Let's call it recursive copy. Handling C directories. For the CP command. Let's detail it. We are able to copy small as well as large files. However, we need to be able to copy directories as well in both the directions. Since English is funny, I can choose to pronounce however I want. Not really, but yeah, I sometimes feel like we can pronounce either way we want, right? I'm sure not. I'm not the only guy who thinks so. So this is done. Yeah, this is important. So why do we have to? Let's create another issue. Right now the file size for a directory is always set to 0. However, it would be beneficial to have this value set to the sum total of all file sizes. Preview file sizes inside file sizes for entries inside that directory. So for example, if a directory contains 3 items, out of which 2 are files with 1 GB files, each of size 2 GB, and another directory whose contents amount to a total of say 1 GB, then the file size of the current directory shall be set to 2 plus 2 plus 1 equal to 5 GB in bytes. So this entry file size saves the size in bytes. So this is what I mean. Alright, let's go to new issue. This is done. Think about sequencing. Nice. So the reason I came to this was, see, copying directories from one point to another might be a long running task, and sometimes some tasks might require more time than we actually think we want to give. What if you close chamber while it's running, while it's copying, or some power outage happened? We are leaving the ability to keep the database non-corrupted on SQLite, right? But I would love for chamber to be able to resume back the copying process when it starts. I mean, that is one of the ideas that I had. So this would be like if you are trying to copy a directory, then basically what I was imagining was it would generate a list of tasks of create a directory, copy this file from this fs path to this chamber file path, path inside chamber, and create a sequence of those tasks and process one after another. Obviously, this is not a great idea because that's not what normally the tools do, but there were other things that were in my mind related to longer term vision of chamber itself, which is why I was thinking about it. So I don't know whether I'll be implementing this or not, but I can at least create an issue. I can close it later if I don't want to work on it, right? So create the, let's say, tasks table in, sorry again, chamber file. We could use a separate table to list down the things that we want to do, and to list down the things that we want to do, and then write a system to read from that table and execute those tasks, more or less like a background job management system, background job management system in a typical HTTP based backend. With a web service. Nice. What are the use cases? Use cases and benefit. So the first benefit is, and this I see as something that might be required at least on sequential disks. This would be useful at least on sequential disk and can be very useful for times when we want to do a lot of IO in parallel. Think about copying a directory, let's say a source directory with hundreds of thousands of files, and you want to copy those files into chamber as well as copy out a set of files as well. So the amount of pressure that will be there on the disk, on the SQLite database, and the lookups and everything that will go on might be in a pattern where trying to do those things in parallel is going to slow down the system overall. So if the copy in took 10 minutes and the copy out was supposed to take, let's say, 5 minutes, totaling at 15 minutes of activity, and if you try to do those in parallel, because of how locks work in any database and how you will write programs and the memory usage, how OS deals with all of this, all of those will come into play, and it will delay the total amount taken for both the copy and copy in and out by a significant amount, right? Another use case that I think is, you see, I do believe that I want chamber to be able to do long running tasks reliably, right? So for example, your chamber file, let's say, contains a very long list of files. The number of files is pretty huge. Let's say you stored, again for an example, source tree, right? So the number of files might be quite big. Imagine node modules, man. Imagine a node based project that you just copied into chamber. So now you have, say, 100,000 files, and what you want to do is you want to change your password. Changing your password right now is going to change the encryption key, which means that I need to re-encrypt everything using the new key and save it. Now this is a long running operation. What if there is a power cut? What if the disk that you were storing chamber file on gets disconnected? You pulled out without letting the operation complete. It might be a mistake, it might be a act of nature, something of that sort. In such a case, although again I'm leaving all of this to SQLite, right? That SQLite will take care of it. the integrity of the files will be there. But what about the pending operation? You change the password, and if you change the password, and this was a long running operation, some of the files have been re-encrypted and some of them are still pending. In such a case, you stopped the process, the database got detached, the data storage got detached. What happens when you plug it back in, right? uh, Ideally you should have a stable state, right? But if you had, 100,000 files and you were doing this long operation, the only way to guarantee, I mean, there are two ways to guarantee a stable state. One is that you copy over everything, I mean, re-encrypt everything internally and then switch over to, the new files. Or second, you uh, re-encrypt every file individually and save their state. If you want to take the first route, in that case you will have to do the re-encryption of all the files in one go, which means that you would effectively duplicate your entire chamber into 2x the storage. Every file will have two copies of it, the previous copy and the newly re-encrypted copy, right? And unless the entire re-encryption operation is complete, your password has not yet been changed. This operation effectively takes a minimum of 2x the storage on your disk. So if you have, let's say, a 100 GB partition and your chamber file was, let's say, 60 GB, you can't do this using the first approach, right? You will have to have extra 60 GB of space, but you'll not be able to do that because there's only 40 GB available. So this becomes a problem, and it is also a big problem on mobile devices. If we ever write anything for mobiles, that is going to be a problem. Mobiles are short on both compute power and storage compared to a regular laptop, at least normally. Mm, in such a case, it would be very beneficial to create that long running operation as a series of tasks and then lock all operations, all ongoing operations, and finish that first in sequence. And then we have everything, working properly. Your re-encryption happens, and in case something went wrong, we'll be storing both the old password and both the old hash and the new hash, and you will probably have to enter both the passwords again to actually start the re-encryption process when you reopen this chamber file later after the assumed or imagined crash, and it would work, right? It will keep continuing that operation for the rest of the remaining files. So that is my thought process behind this, creating the tasks table in chamber file. And this is something that I'm thinking long term. All right, that's quite a bit of mouthful. So I hope you understood, but I'll write some part of that detail in this um, issue itself. Hopefully that will be good enough. Okay, so first thing is, I think that is the biggest use case. Benefit or any operation. Let's make it heading 2. Why did it start with heading 3? I don't know. For any operation long, this is not a word, requires to perform a series of operations which take time. For example, Reindexing, not reindexing, we'll do the indexing things stuff later. uh, Validation or verification of contents, re-encrypting the contents for a new key slash password, copying large number of files in any direction, etc. Take time and can potentially demand a lot of storage for the action as well. Breaking the task, the entire operation into smaller tasks and keeping track of those will be much more much easier, as well as safer, right? It would also allow us with some, okay, obviously this is all code, us to defer the execution of one operation after another. For example, let me not use brackets everywhere. We say this is full stop. For example, I don't like using e.g all the time. I don't know why, but I just don't. I think writing full words of for example are better, because eg, I think it stands for exempti gratia or something. What does e.g stand for? Exempli gratia, which translates for example. So eg just doesn't fit in my mind as for example. I mean, it should be fe, right? Anyways, small stuff. I would also allow us to defer. It will all. Sorry. It would also allow us to defer the execution of one long-running operation after another, and help in achieving the end goal faster and more reliably. Why am I saying faster? Is because there is, at least not in my knowledge, there is no storage media where the write operation is faster than the read operation. And there is no way that if you are doing both read and write on the same file at the same time, it's gonna be good performance wise. It will always be it will always take more time being done parallelly than it would take being done sequentially. It doesn't always only depend on the amount of memory you can use or the kind of storage you have. Those are there, they play their own roles, but it also complicates the kind of software I want to start off with. I want to keep it simple. I want to keep the memory usage low. So if I am declaring a variable which holds the current file under operation, and I'm trying to do two things at the same time, not only will it have some kind of a lock contention. I know that there are mutexes and there are read-write mutexes, but they have their own peculiarities. They have their own patterns. For example, if you use RW mutex in Golang, and you are writing more than you are reading, then RW mutexes tend to underperform. RW mutexes were designed for being used in cases where the writes are lesser than reads. That's where they outshine, the regular mutex. But if you're doing both at the same time, RW mutexes, they will, you know, not perform as well as you would like. Again, if you're doing both the operations at the same time, you need to have two different buffers operating for write operation and for read operation. In addition to that, you are asking your program to read from the same file, right? And on the OS level, it depends on the OS obviously and the storage media. But if you are trying to read and write from the same file at the same time, there has to be some kind of a race condition that happens. Maybe not a deadlock one, but uh, it may not lead to a deadlock, but it will always be, cutting the performance into more than double. Increasing the performance. What am I speaking? Basically, the performance will be hit enough that it will take more than double of the time, more than the time it would take for those operations being done sequentially. Apologies for that last sentence. I totally messed it up. So, if, for example, say it, you start a read operation. Let's say we are going to assume copy 100,000 files of varying sizes into let's say we are trying to perform the following operations. I'll give you multiple views of these things coming into play at the same time and how it would affect. I hope at least I'll try to give you a fair bit of idea of how this might not be great to parallelize. But anyway, let's see. Read, copy various sizes from chamber. Okay, chamber to the disk. In this case, we are reading from chamber file. Okay, we also want to write, let's say, copy 50,000 files, maybe 50,000 files of varying sizes, but roughly the same cumulative size as the read operation. In this case, we are writing to the chamber file, right? And let us throw in another thing that you want to do. For example, like I said just now, re-encrypt, right? This will both read and write all the files in the chamber file, right? We will read each file, encrypt it with a new key, store it, update the index if applicable, create the file index or FS index. And delete the old block just say accordingly. We don't need to do that. So we are doing both read and write. So we are doing both read and write. So I will tell you how this kind of a tasks table is going to help. how having a tasks table would help. Okay, let me first create the issue so that I don't lose all of this text. I'll update it. Done. Let me edit it now. So first, imagine running these three operations at the, let's not do a 1 here, at the same time. What are the challenges? One, this is keeping track of which operation each file has gone through and is pending for. Keeping track of each operation on each file, right? We have to make sure that all the old files have been re-encrypted, and if there were new files created as a result of in-copy operation, let's call it copy in operation. Copy in means copying into the chamber file operation. They would have to be encrypted with the new key only, but we have to guarantee that the old password still works, since till the copy operation, the re-encrypt is not done. This is complicated to track. You can employ any number of strategies to deal with it. This including a record keeping table for each such operation, or a flag in either the file blobs table or the fs index table, or create another one. Okay, that we have already covered, table or something like that. But the complexity for such an operation will remain high. Sequencing the entire operation to smaller, all the operations, sequencing these long running tasks would help us keep track of the tasks and the long running operations. Let's call it operations by breaking them into smaller tasks that can be done in a sequence. helps avoid the complexity. Remember one thing, when I went to the introduction, fault tolerance and verification is one of the things that I want to focus on. If one needs to choose between fast or reliable, the software must stay reliable. I want to focus on reliability. Have wrong results fast? No. Having wrong results faster is not desirable over having correct results later, right? I mean, this is not going to affect the performance in any way which takes significantly longer than a parallelized workload would, because we are dealing with the same files here, right? So that's there. Avoid the complexity and improves the reliability. Now the thing is, if I have such a big point, it is better to put it under a heading rather than as a point. Okay, now 1 2 3 4 total time taken would be lesser. Let's update it and let's come back so that I don't lose all of it. Let's go and edit. The storage media is a SQLite file, a single one for now. Speaking of which, we can create a new issue and say allow a chamber file to be split into multiple ones. Splitting of chamber file. Yeah, it's a SQLite file, a single one for now. Until number 7. Let's see if it has got number 7 gets completed at least. If you try to parallelize so many read and writes, there are at least 3 factors that kick in. 1. The delays introduced purely by the storage, not storage, storage media. Okay. The second one is the resource allocation on OS level, and the third is resource allocation and management in the code. Okay, so what am I trying to say here is, if you have a SSD connected to a fast enough bus such as PCIe, you might think it will not have a significant impact on performance. But if the storage is a memory card like a micro SD, USB, pen drive like a micro USB or a USB pen drive or a HDD with spinning disks, etc. Then the parallel reads and writes are going to cause a lot of delay because of how storage systems work. Basically, the reads and writes cannot go in parallel at the same time. I mean, it can, but it requires that can happen only on a well engineered and fast enough disk, right? Usually, if you're trying to both read and write from a single storage media, it's going to take time because both the operations can't be serialized. I mean, parallelized down to the chip level. The storage controller will take one read request and fulfill it, and then it take another write request and then fulfill that. It can be happening that way. Or if you are on a spinning disk HDD, doesn't matter. I mean, how good the controller is designed, your disk will only move at a certain speed. The movement of head from one track to another takes time and so on. I mean, if you don't know how an HDD works, go look on YouTube how they work and why this is a limitation. It will probably give you an idea. So this is one, right? Resource allocation on OS level. That's oops, sorry. Oops, I keep pressing wrong keys. The OS scheduler would have to allocate the same resource, which by the way is your SQLite file, in a way that allows for both reads and writes to go in as fast as possible, depending on how the scheduler works. It will anyway get serialized or take a performance penalty at a minimum. Remember, sequential reads of even smaller files is always going to be faster than random reads of those files, and it is going to be true even for SSDs, at least for contiguous data. It's going to be how the storage media will behave. So this, I mean, I can add that as a point here, but it's already wordy enough, isn't it? When I say code, do I mean to say the code we are going to write? No. When I say code, I mean both the logic that we would write into our application, which is Chamber, as well as the SQLite implementation, in which in our case it is that GitLab / Sysnic / SQLite, that thing, right? The driver that handles these, the operations against the database might also introduce its own complexities, decision making logic, and analysis of what is going on. It's not exactly going to be an analysis, but you know, it kind of is. Like, you have to look at various available variables at play. Like, is an already a is the database logged, is it not logged, what kind of lock was established, can I alter this table right now or not, is a read going on, and so on and on, right? Going on, so such as locks that are active, acquiring and releasing them, managing transactions, etc. On top of this, we have to write our own logic to manage multiple operations, right? If we have a tasks table which contains a sequence of operations, sequential breakdown of what we intend to do, the above mentioned three operations, then the total time, then the total effort would get simplified, which means, for example, less number of locks and checks, less load on the OS as well as the media storage. One kind of operation, basically. One kind of operation is happening at one time. It's gonna always be faster. Also, you have to remember that whatever media you are using, it's not just your program, like not just Chamber that would be running, right? You might be doing, or your OS might be doing 10 different other things at the same time in the background. If you have given these three things for the operation to be done on your storage media, in Chamber, which obviously is going to affect your storage media. And on the side, you're downloading a file, you're also web browsing, which generates its own list of caches and lookups in their own databases. You're also coding on the side. All of this is happening at the same time. If you pressurize more, if you, this is going to take time. If you remember, older systems used to hang more or less, right? If you take a modern operating system, let's take a bad one, Windows 11 for example, and I'm calling it bad because I have seen a computer that was fairly good enough for Windows 10 nearly choke up and stand still with Windows 11. So Windows 11 requires a lot of resources. So you take Windows 11 and you install this thing on a spinning disk, and then you try to do 5 different operations. It will feel like it has hanged. You will end up frustrated. You'll probably reset your system. I don't know, if you're angry enough, you'll break your laptop. So you don't want your system to get into that state where it feels hang. And one of the best ways of doing that is to let things happen sequentially. And I'll give you another example in the same in the same mental space. So let's say you start a Windows 11. Again, let's take Windows 11 as an example because it's resource hungry. So you start your Windows 11 computer. It has been it has got a spinning hard disk which usually does everything sequentially, and you try to open 3 different programs, let's say Chrome and Firefox, and let's say Word is a heavy one. I mean, all three are heavy. And you try to open all these three in parallel. Take the, recall the time it takes for all these three to launch properly and become usable on your screen. And I'm saying this for a system that is resource constrained, maybe say 4 or 8 GB of RAM, and you have a spinning hard disk, that kind of a situation. And measure the time taken when you launch all of these three programs at the same time, like click click click, right? And you launched all of three. You at least requested the operating system to launch all three in parallel. And then what you do is you time the sequential launches again. Okay, this time, I mean, like I said, sequential launches. You click on, let's say, Chrome's icon, wait for it to come up on the screen, start functioning good. Now we click on Firefox, let it come up, starts functioning great. Then you click on the Word icon, let it come up on the screen and become functional again. And then you check how much time this has taken. I am betting you that the sequential time will be lesser than the parallel launch time. Okay, and this is because of all these factors. The delays introduced by the storage media, that is always there. Sequential access is going to be much faster. Okay, resource allocation on OS level, if you are trying to use the same disk for three different operations at the same time, the OS also has to make decisions on what resource to allocate to which process when, right? This takes time. And if you know about context switching and how operating systems switch the context between different processors and how they wait on those, about the interrupts they handle and stuff like that, you'll get to understand that doing parallel stuff is not always great. And this is why this spinning HDDs take a lot of time to get things done, is why SSDs are great. Not only is there the storage media great, the controller chip on them is also much better, because it knows that yes, I can handle 20 things at the same time. But even then, most of the time it's only processing fast enough that it looks parallel. It gets the commands not in parallel but in sequence. I don't think it gets commands in parallel. There is practically no way of doing that on the electronic level. I mean, there is, but those are always going to be very very difficult to implement compared to a serial one. Which and this serial behavior being easier to implement is why you see so many devices using USBs. Before USBs, you had like so many different kinds of buses. There was PS2 that I have seen. There was Firewire. I think it was called 1397 or something. I remember that there was VGA. Now you can do USB connection. Now obviously it's now called Thunderbolt. But yes, the sequential stuff is always faster for the same storage. Another example, just for the sake of it, take one hard disk, have two files on it on different partitions most probably, and copy your file, and let's say start copying multiple files at the same time from one directory to another. Do it for directories or files that are going to take time. Notice how much time it's going to take for stuff to happen parallelly and to happen sequentially. Now what you do is you take two disks, one your internal disk, another you attach via USB or something, right? Given it's fast enough, at least the bus should be faster than the disk. And try to do the same thing. I mean, try to copy paste files from your system into the USB drive that you just plugged in, or from the USB drive into your system, and notice the time it takes. When two disks are there, the total amount of work needed gets divided into these two, and then it works faster. I mean, there are endless number of not endless practically, but there may be at least a few dozen number of examples that can be given for this behavior, right, which we are trying to avoid. And since I don't know, as a person who is going to build the software, I don't know whether a person is using HDD or SSD, or he is using a memory card or a USB pen drive. I mean, I think that I want to build it for mobile someday, and for that I need to consider this. What if my chamber file is on a USB drive actually, or on an external hard disk that is a spinning disk? And I do have those disks. I have a memory card, I have a couple of pen drives, let's say 32 or 16 GB. I think I have one with a larger storage, but anyway, that is not the point. I want it to function well on all of this, so this would be a great addition uh, Again, this is not something that I'm gonna work with right away, but I'm just noting these things down. I'm creating issues, right? So let's say conclusion backing the decision, right? uh, Given all the possible scenarios, use cases and environments that chamber might be executing under, it would serve us better to have a tasks table and read from it for longer operations and use it for longer operations. Okay, so we will implement it. Let's say an additional node, that's kind of a final node. We will not work on this for the alpha release, right? Another one that comes into mind is set a nice license, man. Set a license for the project, right? I mean, I have to create some rules on who can use it, who cannot use it, who should not be using it, and for what purpose. I mean, chamber, anything that can create secrets can be used for something harmful, right? I mean, I don't care about that. Law enforcement should be caring about that. There are enough number of open source implementations. Some of the popular ones like OpenSSL or GPG, they're also open source. So that is not my problem. But like I said in one of the earlier videos, that I don't want to host this project on a system which uses or reads code without explicit consent of the creator for training an AI model. And I know that they are going to sell that AI model back to us in some way or form, and I am not okay with that. This is the second time I'm saying it. I'm not okay with that. Okay, so I mean, for me, I mean, this is going to be open source anyway, so it's fine probably, but I don't feel like I want that to happen with my source code. I can probably put this on GitHub, but I also might not. I mean, that is not yet decided. I'll give my thoughts to this in detail later. It will take some time, and until the time I am able to come up with a good enough license. I mean, there is legalities behind license, and I'm not a lawyer or anyone who knows law to any significant degree. I would defer this for some time. Until then, TechRail/chamber stays private. No details needed here. Lovely. Let's go back to issues. These have been created. Fix the SHA hash calculation for the entire file while it is being copied in from the file system to the chamber file. This is also going to need calculation for the entire file. Okay, let's create the details. When a file is being copied into a chamber file, we need to calculate the SHA-256 sum of the file of plain text version of each chunk, or as we say it, blob. I might have to rename that file underscore blobs to file underscore chunks. Each chunk, encrypted version of each chunk, a plain text version of the entire file, encrypted version of the entire file. Uh, Probably since each encrypted version of a chunk will have a nonce added, I think it is prepended to it. Should I create that? Should I? I mean, I have two ways of doing it. I'll keep it simple. The nonce added to it, the encrypted the SHA-256 sum of the entire file of the encrypted version of the entire file will essentially be the SHA-256 sum of all the encrypted chunks assembled in the same sequence, and thus will not be the same when the same encryption algorithm with the same keys is run on the entire file. Let's make it clear, it's a very long sentence. Hence, this hash will not be the same as that of when the same encryption algorithm with the same keys is run on the entire file in one go. Okay, important note. Let's put it as important note. Create issue created. This is easier to do. It is also easier for someone to do the same thing using a third party script of some sort outside of Chamber if they wanted to verify if the encrypted value is what they are supposed to have. This is going to be easier. Anyways, I guess I have covered everything that I wanted to from this list at least. This video has been long. I'm going to stop now and maybe pick up one of the tasks, most probably this, in a separate video. See you again. Bye bye.